So exercise material, which is related to stress, strain, and the Young's modulus. We'll start with question 19 for this exercise. So question 18 and question 19 here. In question 19, a Newton meter is used to be used over a greater range of force. Which of the following should be increased to allow this? Like what we want it to work for a greater range of force. Like we can record, say, from 0 is there, from 0 to 100, 0 to 50. If we want to increase the range, what we should do to the spring balance or the force meter? So we have option. If we increase, look, the size of the spring balance is same. It's constant. And here is a pointer. Example, here is a pointer. And we attach a load here. If we use the ductility of the spring, like a spring inside it uses spring. If you use the ductility of the spring will stretch more. If the spring will stretch more, as a result, it won't be in the same scale. Because what we want more numbers in the same size. So we want to reduce the spacing between the numbers. Like we don't want it to stretch more. We want it to stretch less, because like there's a spring inside. As the spring stretches, the pointer will change. If the spring stretches more, as a result, we won't be able, like there will be, for example, if this is 10 Newton, if a spring stretches more, this will be 20 Newton, this will be 30 Newton. But a spring stretch less, so example, this is 10 Newton, this is 20 Newton, 30 Newton, 40 Newton, 50 Newton. So we can record a greater range of the values. So what should be increased to allow this? Ductility? No, it should not. We should not increase the ductility. We should decrease the ductility. Precision of the scale. Precision of the scale, like recording the smallest value. Precision increase only the sensitivity, not the range. Like the number does not change, but we'll have more marking. Example, we'll have more marking between 10 to 50 or 10 to 20. That means this will have no effect on it. If we increase the stiffness, so as a result, when we increase the stiffness, higher stiffness means a small change in length, because higher stiffness means greater value of the Young's modulus. Greater value of a Young modulus means more stress and less strain. And smaller strain means smaller change in length compared to the original length. So we want a smaller change in length, that's why stiffness. Ultimate tensile strength. Ultimate tensile strength means like maximum force which can be loaded, like the force which will break the spring. But if we increase the ultimate tensile strength, it will need a higher force to break down, but it won't follow the Hooke's law, because when we are using the spring balance, we want the stress to be directly proportional to strain. Ultimate tensile strength are the point after that. So when there is the ultimate tensile strength, like the strength or the force or a stress at which the object break down, so this is a breaking point. So these points are after the elastic limit or a proportionality limit. So if we change them, the spring can hold a large mass, but it won't follow the Hooke's law, or a stress and strain will not be directly proportional. So we won't have a linear scale. Like for this type of change, what we have to do, then this should be 10, 20, then 30, and then 40. So which is not correct, because the scale should be linear. So if we change the ultimate tensile strength of a spring, because ultimate tensile strength is usually after the limit of proportionality or the elastic limit or yield points, so the spring will not obey, so we won't have a linear scale. So if we want to record the greater range using a spring balance, so we should use a stiff spring so that it will show a smaller change in length, and we can record greater number of value in the small intervals. Is it clear? Question 19. The difference between a limit, elastic limit and the proportionality limit. Limit of proportionality where the stress, strain, or the force and extension are directly proportional. That is the limit of proportionality. After that, it won't, for stress and strain are not directly proportional, or force and extension are not directly proportional. So there is another point which we call elastic limit. So if we remove the, like beyond the limit, if we remove the force before this point, the object will return back. But if we remove the force after this point, the object will not return back. So the difference between an elastic limit and a limit proportionality limit shows that they are directly proportional, like stress and strain or force and extension are directly proportional. But elastic limit means beyond this point, the object will not return to the original shape and it will deform permanently. And usually elastic limits are the points after the limit of proportionality. And it's not in a linear region, it is after the. Some objects have the same limit of proportionalities and elastic limits, but most of the objects have different elastic limits. Question 20, some masses are added to a piece of a copper wire. Measurements are taken. The length of a wire as a force, the length of a wire as a force of a wire is increased. So which graph correctly shows the relation? Change in length, which is a extension. So for the wires, what usually happens for a wire, if we have force on y-axis and extension on x-axis, first it is directly proportional. Then we have a limit of proportionality, elastic limit, like limit of proportionality, elastic limit, and then there's a yield point region. Yield point means a very small change in the force, there's a maximum change in length. So for the graphs, for the wires, we always have a yield point region. So when we check this graph, change in length and force, we are increasing the force, the length, change in length or extension is also increasing. So it's for a very small change in a force, there's a greater change. But when we plot these quantities, so either A can be an answer, like A is not wrong. What about stress and strain? Because some masses are added to a piece of a copper wire, measurements are taken of the length of a wire and the force. So we take the measurement of a length. So if we take a measurement of length and force, so we cannot plot the graph between stress and strain. Because we should know, to get the graph for a stress, we should know the area, like force over area, and strain can be there because change in length over original length, it can be, but stress cannot be because we should know the area. That's why B and C cannot be an answer. Then we are left with option D, which is the change in length. This is also change in length. Here's the force, here's the force. So for a very small change in force, because usually why we prefer this graph between force on y-axis and extension on x-axis, because the gradient of this graph will give us a stiffness. K will be F divided by delta x or delta L. F is, so using this graph, both graphs are correct. Even A is correct, D is also correct. But why we will prefer to plot D rather than A? Because gradient of this graph will give us the spring constant, which is K. So K is equals to F divided by delta X. So using this graph, we can directly work out the stiffness or the spring constant or the stiffness, because it's a wire, so stiffness. Why we don't prefer to plot this graph? Because after plotting this graph, if we work out the gradient of this graph will be delta X over F, which is reciprocal of the K. Then we have to take a reciprocal of the slope to work out K. So we prefer D rather than A. Is it clear? Question 21. The graph shows a stress strain curve A, B, C up to a point of a fracture. Identify which of the material is a brittle. What is the definition of a brittle material? The brittle material, it shows no or very little plastic deformation and it break down. So it should not show. What you will check if you want to check a brittle material, the one which is having a smaller change in length. So which is no or very small deformation. So A is having a very small deformation because this is a deformation for A. This is a deformation for B and C. So A shows a very small deformation. That's why A is brittle. So the first condition for an object to be brittle, it should not show any no or very little plastic deformation and the object break. The next is the ductile material. To be a ductile, even B and C both are ductile. But what we check area in the plastic region. Like say this whole region is a plastic region for B and this whole region is a plastic region for C. So you can clearly see that B is having a large area of plastic region as compared to that of C. So the ductile is B. For the strongest material, if you want to check the strongest material, we check the maximum force which break the object. Like the fracture point. So we just check the y-axis, the tensile stress. So which one required a greater amount of force to break down? So A required a greater amount of force, so A is the strongest. Least stiff. Most stiff is A. Least for stiffness, you will check the angle. The initial angle, not the final, the initial angle. So the one which is having the smallest angle is least stiff. So that's why C will be the right answer. The three materials are copper, glass, and steel. Identify. First, copper, which is a pure metal. So pure metals are highly malleable, like they can easily deform. And steel is there, which is in alloy. So alloys are difficult to deform. So this will be steel. This will be copper. And A is the glass, which is a brittle material. Explain why steel is suitable material for making paper clips. So what is the reason why? Like you have to just refer the properties. Steel is stronger than glass, but it depends on the, because look, this parameter is not, they did not mention we have same parameter, like same size of a glass, same thickness of a glass. They may have a different sample, like maybe the glass which is used for this experiment might be thicker as compared to that of a steel. So this comparison is not done on the same scale. That's why you're getting a different values. If the steel which was used, that like example having the same thickness as the glass, then in that case, yes, definitely the steel will be difficult to break, because they did not mention identical samples are there. They just mentioned we have three different types of material. So why a paper, for a paper clip, why we prefer to use a steel? So you can mention first thing, because when we are making a paper clip, so it should be ductile, like we can draw them into wire, and it should be malleable, and it will have a high Young modulus or the stiff, so it will not deform easily. So you can mention those points, and high breaking point, so it will not break down easily. And state the name for a point marked X. So X was X is because it is parallel. This region is parallel to the strain axis or extension axis. So we call that as a yield point. And explain its significance. What is the significance of a yield point? Yield point means like it's a point at which the object will show a maximum change in length or a great larger change in length for a very small change in force or no change in force. You can also mention that. A thin wire of a uniform cross-sectional area is stretched by an increasing force. The corresponding stress strain graph is there. W, X, Y, and Z are shown on the graph. Select the row in the table. Identify the yield point, the limit of proportionality, and the elastic limit. First thing, to identify the yield point, so we just check the point which is parallel. So which point is parallel to the strain axis? So this region. So Z is the yield point. Limit of proportionality, the last point where this line is straight. So this is the limit of proportionality. And now we are left with 2 points, X and Y, both can be elastic limit. So we just check the option. Z is the yield point. W is the limit of proportionality. So we are left, both X and Y can be elastic limit, but because with option B, in which two of them are correct, so that's why Y should be the elastic limit. X can be elastic limit, but Y we select because according to the sequence of the two right answer, it can be X or Y, but according to the sequence of the right answer, it will be Y only. The force applied across the end of a spring. So here at R, as you can see, we are increasing the force, extension is also increasing. So means spring will be stretched. At Q, there is no force, so the spring will be normal. And at P, like extension is negative and force is in opposite direction, so the spring will be compressed. So at P, the spring should be compressed, Q, it should be normal, and R, it should be stretched. So it matches with option A.